In the last video, we introduced factoring and looked at how to factor an expression using a bar model. But sometimes a bar model does not work to factor an expression because of the way the expression is built, like it has negative signs involved, or maybe we just want another method that doesn't use a bar model at all. So we're going to use a method called factoring using the greatest common factor. We want to use the greatest common factor, or the largest number that can be factored out, to factor it completely. So think of this greatest common factor as the number of groups that we're making, and we're always going for that largest amount of groups. So here's our process for finding the greatest common factor. Our first expression is 15x plus 9y. So I would use a Venn diagram to figure out what my greatest common factor is for these numbers, or these terms, and what's left in each term when I take that out. So for one of my circles, I'm going to call this circle, everything in it will be 15x, and in this circle, everything in it will represent 9y. And then I'll think about the factors of 15x and 9y. Well, 15x is going to be 5 times 3 times x. And 9y is going to be 3 times 3 times y. So I'll fill these things into my Venn diagram over here. The first thing I notice is that these two terms have a 3 in common. So I'm going to put that 3 in the middle. And that's the only thing that they share in common. So over here in 15x, I'll put my 5 and x that are left over. So 5 times x. And in 9y, I'll put my 3 and my y in here that are left over, 3y. Once we've organized this whole Venn diagram, we've basically factored this expression. I could write 15x plus 9y. I would say that that is equivalent to 3, which is our greatest common factor. It's also the number of groups we could make out of this expression. I would say this is equal to 3 times the leftovers in each group, 5x and 3y. So let's check this out. I'm claiming that 15x plus 9y could be rewritten as 3 times the quantity 5x plus 3y. Or I could also check this by looking at what would happen if I distributed it back out. Because if you remember, factoring is that process of undoing distribution. So we can always check by remultiplying. So 3 times 5x is equivalent to 15x. And 3 times 3y is equivalent to 9y. So these two things are equal to each other, and we've used our greatest common factor. We've pulled out the greatest factor possible, which means that we've fully factored our answer. And we're done. Let's do another one. So our next problem says 2a minus 10b. So this is a problem that we could not use a bar model for, but we can use our factor using the greatest common factor method to great avail. So as always, I'm going to tell you to take that minus sign and make it add the opposite. By doing that, I don't have to worry about what operation sign will be in between my numbers because I know I'm just going to write an addition at the end. So let's start by setting up our Venn diagram for my two factors. I have 2a, that I'll do in blue, and my purple, I'll do negative 10b. And I'll think about what numbers go into 2a and negative 10b. So 2a is going to just be 2 and a. And negative 10b is one I'll have to break down because it's not prime. So I know that 10 is broken into 2 and 5. And then if it's 10b, it would be b. But to make this negative 10b, I'm going to say that it has a factor of negative 1. And that factor of negative 1 is going to be what makes it negative. So let's fill in our Venn diagram. The thing that our two numbers share is that they both have a 2 in it. So this is going to become my greatest common factor possible, and I'll fill that into the middle here, into my GCF spot. The overlapping factor, the common factor. And then I'll take and I'll write what's left in each of my numbers. So if I have the 2 out of 2a, I'll just have an a left. And if I divide the 2 out of negative 10b, I'll have negative 1, 5, and b, which I would multiply this all together to get negative 5b. Now I'm ready to have it fully factored. So I say that this expression here is equivalent to my greatest common factor, which is 2, times the leftover parts of each of my terms. So my first term was just left with a, and my second term is left with negative 1 times 5, negative 5b. This 2 times a, okay, that's 2a, and 2 times negative 5b is negative 10b. So it does check out that those are equivalent. And I could leave this as my final answer, but I think that I'm actually going to rewrite it as 2 times a minus 5b. So I don't have double signs going on. That would be a better final answer. Two more problems. In this third problem, negative 16x minus 24, we're probably going to have a lot more in common between these two numbers. So as always, I'm going to start by rewriting subtraction into adding the opposite. Then I'll take each of my numbers and I'm going to break them down into their, thinking about their factors here. So for negative 16x, well, it's negative, so I'm going to put a negative 1 in its factors. And there's an x, so I'll put an x in its factors. And then I'll think about what else goes into 16. So 16 could be broken into 4 and 4, and then 2 and 2 for each of those. For negative 24, there's also a negative 1, and I'll break down 24. I have 6 and 4, 2 and 3, 2 and 2. With my red marker, I'm going to go in and fill anything that's part of the greatest common factor. So I look at the parts of these factor trees that are in common with each other, and I see that there are 3 sets of 2's. All right, 1, 2 from each pair in there. And then I also notice that both of these numbers share a negative, so I'm actually going to put that negative sign in the greatest common factor spot instead of in with the numbers themselves. I'll browse through my list and see if there are any extra things I need to put in here. So 16 has an extra 2. I'll write that in its circle. And 24 has an extra 3. I'll write that in its circle. Now I need to determine my greatest common factor. So my greatest common factor of these two numbers is going to be 2 times 2 times 2 times negative 1. So the GCF is going to be 2 times 2 is 4 times 2 is 8 times -1 is -8.